All right, recording started. This is Friday, May 7th. This is going to be our last live class session for math. We have two more problems left, and then I have to show you the password. But yeah, let's get started on this one. Let's do this. I'm going to give everybody, let's say, 2 minutes to do this problem very quickly. Hopefully, when we were talking before class started, you were working on it. But maybe that's wishful thinking. So 2 minutes, work on this problem, please. And then we'll see what the answer is. All right. Anybody have the answer for this one? We got 3 different answers, looks like in chat. Let's see. Yeah, Emily, if you want to work it out for us on the screen there, I'd love to see that.
Okay, so I don't know why I have a different answer than everyone, but I will show my work. Wait, why did I put in a different vector? What the heck? I put in the wrong vector. I was looking at something else. Okay, hang on, let me do it with I'm dumb, hang on.
Let's do this, Emily. How about you talk me through the steps before I show it?
Okay, so you set it up with the transformation matrix, so B, and then times the vector and matrix form, which is you would do it as a column so it matches the first one.
Mm-hmm.
And then so you would multiply, hang on, I'm going to do the pointer. So you would multiply this by this and this by this, and then add those together. So you do 6 times -2 is -12, and 2 times 9 is 18, and you combine those and it's 6. And then you would do the same thing for the bottom, so you do -1 times -2, which is just 2, and then 3 times 9, which...
Hang on a second.
Or -1 times -2 is...
Okay, so you got 6 for the top, you said? Okay.
And then -1 times -2 is 2, and 3 times 9 is 27, and 27 plus 2 is 29. So I don't know why I wrote the wrong vector to start with. I wrote -2, 1. I don't know what I was looking at. I was looking at something else though.
Meaning glasses.
And I just wrote, yeah, probably.
Yep. And yeah, this was a question from your TGA.
Yeah.
Yeah.
I think I maybe wrote something else in my paper down.
You probably just glanced up and you saw this one.
Because I did the work right because if you multiply the transformation vector by 2, 1, then the work is all right. But
yeah, so for this problem, you got to make sure that you have your matrix first and then your vector. It has to be in this order, just like on your last test.
I did B, and then I did so I did, instead of doing the right vector matrix, the -2, 9, I did 2, 1. And I don't know where that came from, but the work is right for that vector. I just did the wrong vector.
It happens. All right, next problem here. We have to convert rectangular to or from parametric equations. So it says, what is the rectangular equivalence to the parametric equation? And you're given these two parametric equations. You have your x equals 9 cosine theta and y equals 6 sine theta. And the interval is between 0 and 2 pi. All right, so we have to convert these. Any ideas? Any ideas?
Can I throw a random thing?
Tuli, did we answer your question? I just saw your question in chat. Did we answer it? Let me go back real quick to answer your question. Right, so I do these boxes to multiply your matrix times this matrix. So convert this into a matrix, a vertical one. And then all you're doing is multiplying 6 times this number. And then you shift to the right and shift down. So there's your 6 times -2 is here, plus 2 times 9. And that's for this top row. And then the bottom row, we're doing this. So it's the same idea. You're doing -1 times -2. That goes here, plus 3 times 9. So when you move, you're moving to the right on this one and moving down on this one. Does that make sense? All right, good, good, good. So like this, xy times x, xy times. I would not call. You can call this x and y, sure. I would call this a, b, c, and d. So it's a and b times x. I'm sorry. Yeah, doing the way I'm trying to make it fit for what you're saying, I probably wouldn't do it that way. Think of it that way. It's going to be a times x plus b times y for your top row, and then c times x plus d times y. You think of it like that. All right, from here.
I have an idea here.
What's your idea?
Okay, is it for the x? Is it x minus 1 over 9 or plus 1? No, it has been
For
a
the-
minus 1. X minus 1 over 9.
For the
Yeah.
answer?
No. For the cosine theta. To find out what cosine theta is.
Okay, so for this lesson, we talked about a scenario where when you're dealing with parametric and you're converting, if you have cosine and sine in your equations, you want to use, let me show you want to use this trig identity somewhere in your work.
Correct. But we got to find what cosine theta is and what sin sine theta is.
Right.
And to do that, we would divide. This should be the 1. There's not really a 1 there, but like there's an imaginary 1 there. So you got to subtract 1, right? X minus 1 over 9.
Why are you saying subtract 1?
Well, isn't there an imaginary 1 here since there has to be something here?
Like after the cosine theta?
Yeah.
So if there's nothing there, it'd be a 0. 9 cosine theta plus 0.
So it's just x over 9?
Yeah, the only time you would have a 1 would be a coefficient. Like, for example, in front of this cosine squared theta, there's an invisible 1 because you have one of them.
Oh, okay. I got you.
But in terms of like a constant, like what you're saying, like plus your 1, you can't just throw, you just can't pull a dollar out of thin air and throw it in there. If it's not there, it's 0.
So it's x over 9 then. Or 9, yeah, x over 9.
Yep.
Okay.
Yep. So Antonio's saying you need to solve for cosine theta and sine theta for both equations, and that's what he did. So same thing with the other equation, y equals 6 sine theta. You're going to divide both sides by 6, and that's how you get this. So for these problems that involve trig identities and you're converting from parametric to rectangular, you have to use this trig identity. And we can only use this when you solve both equations in respect to cosine theta and sine theta. Because now we know what cosine theta equals, which is this, and we know what sine theta equals this. So we're just going to replace cosine and sine with what they equal, x over 9 and y over 6. Everyone good so far? Emily almost choked and died. So here's a life-saving tip. If you are alone and you are choking on something like a grape, hopefully you have a chair near you. You can use the chair, the back of the chair, to assist with the Heimlich maneuver. Did you know that? You have to stand up. Well, so you have to be conscious for this to work. But yeah, you just stand up behind it, and then you lean over the back of the chair, and you just like drop down on it, and it applies the force to your abdomen, which is like right below it's called the xiphoid process. But yeah, I may have saved your life one day. I don't know. Anyway, so everyone good on this step here? You understand how I plug these two values in? Okay. All right. What do I do next? What do I do next? No, we don't FOIL. This is not a binomial. This is not a binomial squared. This is a a fraction squared and a fraction squared. Yep, there's no foiling. So I see people putting in chat what the answer is, but not actually what you do. So you want to square the numerator and denominator for both terms. And I think that's what all of you are pointing to with giving the answer. Yeah, you want to square the numerator and denominators of both. X squared is x squared, 9 squared is 81, y squared is y squared, 6 squared is 36. All right. What is this an equation of? I think Julia's right. Yeah. This is definitely an ellipse. We know it's an ellipse, well, because it's a plus sign. It equals 1, and the a and the b values, they're different. Now, if they were both 81 or they were both 36, then it would be a circle, and then we would have one more step, which would be to multiply everything by that denominator to clear fractions, but it's not. This is an ellipse, so yep. There's a different x width and a different y width, so it's a squish circle. So if you said circle, you're half right. All right, so we have the equation. Now what do we have to find still? Thule is correct. It is longer horizontally. What do you mean both x values, Antonio?
You find the domain, basically.
Yeah, you had to find your domain. Exactly. Well, that box was way off. Okay. All right, so to find your domain, you want to use your x equation. And all you're going to do is plug in, well, the start and the end. But this one may be a little different because it's a trig function. This is where it's tricky. So if you think of a cosine function, right? Or I'm sorry, cosine function, and how it makes a wave, right? Up and down, up and down. Well, what's the period of this cosine? It's 2 pi, yes. So would that mean the value of cosine at 0 and 2 pi, will they be the same? They will be, yeah. So we don't want to do a full rotation to find your interval. We want to do a half rotation to find the max. So we want to plug in 0 and pi and not 0 and 2 pi. And really for these, I talked about during this lesson, these can be tricky to identify what the actual domain is because they're trig functions, and graphing it is a great way to see what's going on. But that's why we use 0 and pi and not 0 and 2 pi. And we just plug them in and solve them both. And that means our domain is from -9 to +9. And we also could have really identified that in the equation itself. Just looking at the x equation, the amplitude is 9, so it's max value is 9, min value is -9. Talking about like a cosine wave. So because the x value, the lowest value is -9 and the largest value is +9, that really gives away the domain. So different ways to look at this to identify that, or just kind of putting them all together to kind of confirm what we found. So we would write our answer like this: x squared over 81 plus y squared over 36 equals 1. And the domain is -9 to 9. We do. So I'm going to do this. I'm going to very, very quickly go through every problem again. Very quickly. All right. Well, I'm just going to talk about it. I'm not going to really go over it. I'm going to talk about every problem real fast. So find the limits. This is the top heavy, bottom heavy, even. Use the bottom part to really make that determination. Pretty straightforward. Geometric and arithmetic. This one you need to determine if it's geometric, meaning you multiply by some common ratio. Arithmetic, you're either adding, subtracting by some common difference. And all arithmetic, they're always divergent. Geometric, the little trick is right here. Geometric, these are only going to be convergent if your absolute value of your R value is less than 1. So that's when you look at determine if geometric is either convergent or divergent. This one here, this is coterminal angle. So you take the original and you are going to add and subtract 2 pi. You probably want to do it a few times in both directions to just cover the wide range of possible solutions that they may have. This one here, so you want to draw a picture. So the word problem, draw the picture, label the stuff, and then this is a right triangle. So that means we can use the whole SOHCAHTOA. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. Cosecant, on the previous page, I listed this. This is on your trig identity formula sheet. Cosecant and sine, they are inverses. So sine was opposite over hypotenuse. Cosecant is hypotenuse over opposite. That's what you could do for this one. And that will allow you to start at this point versus doing it the way that I showed here. Next problem here. You want to, what does it say? So we want to find the value of the cosecant of theta. It talks about the angle and center position, and it passes through 5, -10. So, we did a little graph. And then this is over 5, this is down 10. So we labeled these sides, use the Pythagorean theorem to solve for the hypotenuse. And once you have that, you can now do cosecant, which we know is hypotenuse over opposite, and you just plug that in and get the answer. This one, you want to do the inside and work yourself out. So we would do inverse. So you probably don't want to type this all in at once because a lot of calculators, they have trouble doing this directly. You type it all in at once. So you want to do arctan of 1 first. Make sure we are in radian mode. So arctan of 1 gives us pi over 4. And then once you have this, cosine of pi over 4 gives you that. Same thing over here. Do the inside first to get this. And then once you have this, you do the arc cosine of this to get that. You really probably want to use your unit circle to do these, but you can also confirm with your calculator too. All right, this one. So this one wants to know the period of the function. Well, here's the formulas to find the period based on if it's sine, cosine, tangent, or whatnot. And we just plug in what's given to us. The k value is whatever's in front of the x, so pi over 3. And then that's how we get 6. All right, this one we talked about. I'm not going to go over it again, but you probably want to watch the first recording because it's actually a lot to kind of talk about. So I would watch that recording again on that. All right, this one, same thing for this one. I'm not going to go in detail on it because this actually took a long time too to explain. All right, this one you're given information, and really the key thing that we need to do to create this equation is to find what your k value is, because you're given everything we need. You're given the vertical shift, you're given the amplitude, the fact that it's reflected over the x-axis makes it negative. So you have to calculate the k value by using, well, that formula I talked about on a few pages ago. For cosine, it's 2 pi over k equals p, and we just plug in p and solve for k. All right, so these solutions. All right, for these, it looks like we want to solve by factoring. So we divided everything by 2 to kind of reduce everything by a factor of 2, and that's how you got here. Then we GCF a sine theta out to get this. And when you do this step to this step and you get this line, distribute it back to see if we get back to the original. So sine theta times 2 sine theta is 2 sine squared theta. And then sine theta times 1 is sine theta. So I would just do that check. So a lot of people, they make a mistake when they GCF. They may forget this 1 here, or they may put a 0, or they may put nothing. And then when you multiply it back out, it doesn't equal to what we started with, and that's bad. So once you factor it, set the factors equal to 0, and then you solve. And that's it. All right, this one, make sure you draw a picture again. This is law of sines or law of cosines. And we just had to basically use those, well, those 2 laws to solve for the missing sides and the missing angles. Ooh, this is a good one too. I would watch the recording again on this one. This is kind of a long one. Yep, watch the recording on this one too. Use your trig identities for this one to make sure you order it correctly. These you probably just type these in your calculator and hit enter, or you can use your unit circle. I think unit circle is probably better. This step right here, this sine of this angle, from here to here, I reduced it by subtracting 2 pi, 6, 12. Yeah, I subtracted 2 pi to get the coterminal angle. And that way I could use the unit circle. But if you typed sine of 13 pi over 6, you would get 1/2. I'm just showing the work by hand to use my unit circle. Either way is probably fine. All right, this one, make sure you watch the recording. This is kind of a long one. Petals. This is pretty simple. The amplitude represents the petal length. If it's odd, that is the number of petals. If it is even, you have to double it. Right, Emily? For this one, you want to use these, and we're going from rectangular to polar. So we replace y and x with what they equal, r sine theta and r cosine theta, and then you just solve. You'll have a question on your final talking about these different ways to multiply complex numbers. I didn't have an example per se because it would just give away the answer. So you want to refer back to your notes on these. Should be pretty straightforward though. All right, multiplying, polar formats. Remember, multiplying, you need to multiply the r values and then you just add the thetas. If it was division, instead of multiplication, you would divide 4 divided by 2, and then you would subtract this theta minus this theta. I don't remember if your final was multiply or divide, but keep that in mind. All right, for this one, it wants you to graph both vectors, your a vector and b vector, and then it wants you to do the head to tail method. So b is second, so we just row. So this is over, was this over 7 and then down 1? So from the end, so the head, this is called the head, this is the tail. So from the head, we would go over 7 and then down 1. And then that is the answer. So we draw our final vector to represent a plus b from the origin to that point. So pretty easy. You've done this on your modules and on your past quizzes and tests. All right, super. This is probably the freebie on your final. This is a freebie. You're given vector A, which is in component form already. It doesn't state it because, well, you need to recognize that's what it is. And then they give you the scalar of -2. So they want you to find, well, -2a. So all you do is just distribute the -2 into both coordinates here, x and y. All right, this one was from today. You should know how to multiply matrix times a vector converted to a matrix. This was a TGA number 2, I think, on your Unit 5 test. Super easy. This was, I think, a freebie on your TGA. All right, this was the last problem we talked about. So, well, just rewind the recording and watch that. All right, now you guys are ready for the password, right? The password. You know what, Sully? I should have made the password because that would have been funny. I should have. You know what? I'm going to make the password. That's what I'm going to do. The password is password. That's funny. Let me go to my, oops. Write this down, password. Oh, you know what? It can't be password because it wants me to have uppercase and lowercase and a special character. Nah, I'll just leave it to what I have.
Wait. I have an idea.
What?
There. That's what you do. There you go. Problem solved.
Let me make sure I can make it that first. Let's see if that's going to work. Okay, that works. We can do that.
Problem solved.
All right. All right. So the password is capital P with a $sign for the second S, and the rest of it's lowercase. So that is the password. By the way, your test will not be it won't open until Monday. So your final is set to be Tuesday next week, but it's going to open up on Monday. All right, everyone. Well, it was fun. Thanks for a great last 2 semesters. I had a lot of fun teaching this class. Sad it's over.
Can we go over my part 2 for Unit 5 quick?
All right, everyone. Well, thanks for coming, and I hope you learned something in this course.